So we're going to try and learn how to balance equations, but before we can even start, we actually have to know what types of reactions there are that we're going to be exposed to this year. And I've put those up as a brief summary. You've met most of them, so what we really want to do is quickly go through and say what generally is going to be made with each of them. Then we're going to use the examples that I've got to try to actually write the formula or the names if we're not sure of what is made. Then what we're going to do is go through a worked example of a precipitation reaction, because the method of doing that works for most things, and time permitting we'll go through a combustion reaction. Okay, so you should have met the first one before. If I react an acid with a base, for example sodium hydroxide and sulfuric acid, what are my two general products?
Salt and water.
Salt and water, great. So I need to have a salt and water, okay? And I'm going to write H2O instead of the word water, because eventually in level 2 you need to write the formula for all of these, so let's put it there straight away. Okay, perfect. A subset of these, because carbonates are bases as well, but they're a special base. An acid plus a carbonate does the same thing, doesn't it? Because it's an acid-base reaction. The difference is because it's a carbonate, you get one more thing. So I'm going to copy salt plus water, but because it's a carbonate, there's one more thing. What is that one more thing?
CO2.
Fantastic. I'm glad you gave it as a formula, CO2. Okay, and I can see the CO2 in there. It just leaves an oxygen left over. Oh, look, there's that oxygen. So they are sometimes the easiest ones to balance. Okay, because most of it's in there. Okay, acid plus metal, slightly different. Anytime an acid reacts, you'll make a salt. Okay, anytime an acid reacts, you will make a salt, without exception. So if you see acid, you write the word salt, and then we'll work out what the salt is in a moment. So, is it salt plus water again? Or salt plus carbon dioxide? Or we'll see it fizzing. Let's give you the observation. What's being fizzed? Oxygen, hydrogen, carbon dioxide, or ammonia. They are the four main gases we need to know about. Hydrogen, spot on. And the giveaway is that it's acids have got H. So that H either has to go into water. Well, you don't get bubbles of water in a solution because you wouldn't see them. But if we're seeing bubbles, then okay, it must be hydrogen, because there's nowhere else for the hydrogen to go. Okay, so H2. Notice it's H2, not just H. This becomes really important for balancing. This is why it's a good way to remember this is our general equation. Okay, let's carry on. Precipitation, I'm going to use the example here of copper chloride and silver nitrate. Can anyone tell me what would actually be made? Which two things? One's a solution and one's a precipitate.
Copper nitrate and silver chloride.
Fantastic. So I have copper nitrate, and I'll change colours here to help us, and silver chloride. The silver chloride is the precipitate, the copper nitrate is the solution. Okay, and yes, this year you're expected to sort of remember nitrates are always soluble, sodium salts are always soluble, those sorts of rules that are in part of in chemistry. They will become really common knowledge to you though the more we practice them, so don't worry about trying to remember them now. So this is basically just swapping things over. It only happens if a precipitate forms. If a precipitate doesn't form, so if you don't end up with solid or going cloudy, then there's been no reaction if they're both ionic solutions. It just means that all of those solutions are present, all of those ions are present in the solution, and none of them have joined together to make the crystal, because the crystals are solids. Okay? So precipitation, you're basically doing a bit of a swap. Okay? So I told my year 11s today, you swap the negative ions, or I said to them second names. Swap the second names or the second bits over. So I would have done this as a word equation first. Copper chloride plus silver nitrate. I would have underlined the two last names and swapped them over on the product side. I'll show you that in a moment because that's part of our process. Combustion. In chemistry, assume it means complete combustion. This means there's only two products that are chemicals as well as the release of energy. What would those two products be? Now here I'm talking about combustion of an organic compound, something with carbon in it.
The carbon dioxide and water.
Fantastic. Carbon dioxide and water for this one. If it were combustion of an element, though, it will make that element's oxide. So sulfur would become sulfur dioxide. Magnesium would become magnesium oxide. So combustion's got two. All right? If it's an element, it becomes that element's oxide. But in this case, I'm talking about combustion of an organic compound, something with carbon in it. So it's always going to be assumed to be complete, which is these two. If it's incomplete, you'd have soot, which is carbon, and or carbon monoxide, and or carbon dioxide, as well as the water. So that's too hard to balance because you don't know how much soot it is, you don't know how much carbon, you don't know. So we always assume it's complete and then go backwards from that. Decomp is actually the easiest one you could imagine because it means taking one thing and breaking it into two. And the decompositions you're going to be introduced to either are going to be things where we drive off water as a molecule or where we drive off carbon dioxide as a molecule. Okay? So I'm going to use the example here because it's easier to show you. Calcium carbonate has a carbon atom in it, so therefore you could expect that it drives off carbon dioxide. Okay? So this one would be calcium something plus CO2. Well, if I count the oxygens, there's 3 of them there, but only 2 of them there. So it's that simple. The other way you sometimes will see a kind of a decomposition would be where something's got a water molecule inside it, and this is shown like this. Oh, shivers, I can't remember how many it is. Okay, apologies if I get the wrong number of water molecules here. Yeah, I can't remember. I'll have to check it. Where we're heating that, and this would become sodium carbonate plus 5 waters. That's all. It's just from being a dot, which means that those water molecules are inside the crystal, it means they're outside the crystal, and they've been evaporated as steam or as vapour. Okay? So there's 2 ways you can see that. Oxidation reduction I'm going to do with you at the end of the year because it's a lot harder. You have to break it apart into what we call half equations and then put it back together as an overall equation. So balancing that would be really, really tricky to do without knowing that process. So the ones that I expect you to be able to do this year are that one, that one, that one, that one, that one later in the year when we do the organics compound. Organics topic, and this one here. So there's 5 I expect you to know how to do now. All right. Are there any questions on those before we move on? Okay, just going to check time. Yeah.